Hello everyone, my name is MEXT, and in this video I'll be going over the MEXT Undergraduate 2018 Math B exam. So I will solve and explain every question. So please know that this is part of a series, and in the Math B 2019 video I give a bit of extra helpful info at the start, but to save time I'm just going to go right into the questions for this video. So first is question 1, which says if x is greater than 0, y is greater than 0, and x plus 3y equals to 2, then 1 over x times y is greater than or equal to blank, with equality if and only if x equals to blank and y equals to blank. So it might be a bit difficult to tell from the wording, but what this question is asking is for you to find the minimum possible value of 1 over x times y and the values of x and y that achieve this minimum. So that should be a hint that in order to answer this question, you probably need to use a derivative. Also, you might realize that if you're trying to minimize 1 over x times y, then that is the same thing as maximizing x times y. Since if you maximize the denominator, you are minimizing the entire term. Like how, for example, 1 over 100 is smaller than 1 over 10. So to answer this question, we need to maximize x times y. So to start, we can write x in terms of y and use that to find what x times y is. So x equals to 2 minus 3y, and if we sub that into x times y, then that equals to 2 minus 3y times y, or 2y minus 3y squared. So in order to maximize this, we can use the derivative, and thankfully this is just a simple power rule. So the derivative of x times y is 2 minus 6y, and to maximize x times y, we can set the derivative equal to 0. So this tells us that 2 equals to 6y, so y equals to 1 over 3, which is the first part of the answer to this question. Also, if you want to make sure this is in fact a maximum and not a minimum, what you can do is find the second derivative of x times y. And you see it's negative 3, so it's negative, which means that the function must be concave down, meaning that this value must be a local maximum. Also, you can notice, you can notice that the y squared term in x times y is negative, which means that x times y must be a downwards parabola, so the point at which the tangent line is 0 must be a maximum. So now that we know that y equals to 1 over 3, we can plug that into the equation for x, which we found earlier right over here. And we find that x equals to 1, which is the second part of the answer to this question. And finally, we can plug these x and y values into 1 over x times y and find that that equals to 3, which is the last part of the answer to this question. So next is question 2, which says the real number solution to the equation 2 to the power of x plus 2 minus 2 to the power of negative x plus 3 equals to 0 is x equals to blank. So for this question, you need to know how to manipulate exponents just a little bit. To start, you can notice that two of these terms have some form of 2 to the power of x, so it might be good to write the whole thing in terms of 2 to the power of x. So 2 to the power of x plus 2 equals to 2 to the power of x times 2 to the power of 2. This is just one of the basic exponent rules. And that, of course, equals to 4 times 2 to the power of x. So we've written the first term in terms of 2 to the power of x. And then the second term, 2 to the power of negative x, is, of course, just 1 over 2 to the power of x. So now we have the whole equation written in terms of 2 to the power of x, like this. And so, it's often useful to get rid of the fraction. So we're going to multiply both sides of this equation by 2 to the power of x. Of course, 0 multiplied by anything is just 0, so that side doesn't change. But this side now becomes 4 times 2 to the power of x squared plus 3 times 2 to the power of x minus 1. And you may notice that this is just a quadratic in terms of 2 to the power of x. So to make that easier to see, let's let 2 to the power of x equal to z. And so we have 4 times z squared plus 3 times z minus 1 equals to 0. So this is pretty clearly just a quadratic. And so now we can solve this quadratic. Thankfully, it's a pretty easy one. Doesn't require the quadratic formula. And if you do this, I'm not going to go through all the steps for time, but if you do this, you will see that z equals to either 1 over 4 or it equals to negative 1. Of course, remember that z equals to 2 to the power of x, and 2 to the power of x cannot equal a negative number, right? An exponential function like this cannot be negative. So z to the negative 1, or z equals to negative 1 cannot be the answer, and so z must instead equal to 1 over 4. That's the only possible answer. So finally, if 2 to the power of x equals to 1 over 4, which equals to 1 over 2 squared, then that means that x must equal to negative 2, and that is the answer to this question. Next is question 3, which says, let a and b be constants if the polynomial x to the fourth plus ax cubed plus ax squared plus bx minus 6 is divisible by x minus 1 squared, then a is equal to blank and b is equal to blank. Now, when you first read this, you might think they had to do some long division or solve the equation, something like that, to solve this question. However, there's actually a very special trick that makes this question a lot easier. And if you want to try it on your own first, my hint is that it involves derivatives. Also, notice that since they are divisible by an x minus 1 term, that means that when x equals to 1, this equation must equal to 0, since x minus 1 equals to 0 when x equals to 1. Okay, so here's a special trick. So this equation is divisible by x minus 1 squared. So what that means is that the derivative of this equation must also be divisible by x minus 1. This is just a general rule, and you can test it to be sure if you want, but that is what's needed to solve this question without spending a ton of time. Also, if the equation was instead divisible by, say, x minus 1 cubed, then the derivative would be divisible by x minus 1 squared, and the second derivative would be divisible by x minus 1. And if it was divisible by x minus 1 to the fourth, then the derivative would be divisible by x minus 1 cubed, and so on. So now that we know that, let's start by finding the derivative to our equation. So it's just a simple power rule. We find that's equal to 4x cubed plus 3ax squared plus bax plus b. And again, we know that both these equations equal to 0 when x equals to 1, since they are both divisible by x minus 1. So let's start by plugging x equals to 1 into the equation. So let's do first just the regular equation. So x to the fourth is just 1, a times x cubed is just a times x squared is just a, b times x is just b, and minus 6. And so if we clean it up a little, we get that b equals to 5 minus 2a. Now let's do the same thing for the derivative. So we plug in 1 for the value, and after simplifying a bit, we find that 0 equals to 4 plus 5a plus b. So we just found b in terms of a right here, and so we can plug it into this equation. And with a bit more simplifying here, we find that a is equal to negative 3. And then of course we can just take a equals to negative 3, plug it back into this equation for b, and we find that b equals to 11. And those are the answers to this question. So next is question 4, which says the maximum value of the function sine 3x for 5 over 18 pi is less than or equal to x, which is less than or equal to 2 over 3 pi is blank, and the minimum value of that is blank. So to answer this question, you need to know, of course, how to analyze trigonometric functions, you need to know the common special angles, and you need to know how to find a trigonometric derivative. So for a question like this, where they ask us to find the maximum minimum values of a function over a certain range, the first step is to just check the two bounds of the range. I went into a lot of depth for why you would do this in my Math Beat 2019 video, so I'm not going to explain that again here to save time, but if you want to understand why I'm doing this, be sure to check that video. There's a question on that exam that is very similar to this one, and I explain why you check the bounds first. So first let's check when x equals to 5 over 18 pi. So the equation is sine 3x, which becomes sine of 5 over 6 pi, which equals to 1 over 2. Also, if you're wondering, this is the special triangle that I use to remember the values of a few of the common angles. I also explain the special triangles in greater detail in the Math Beat 2019 video. So now let's check the other bound, which is when x is equal to 2 over 3 pi. In this case, sine 3x equals to sine 2 pi, which just equals to 0. So now we can find the derivative, which is equal to 3 times cosine 3x. If we set the derivative equal to 0, then we find the point at which our equation has a tangent to 0, which can possibly be a minimum or maximum. So if 3 times cosine 3x equals to 0, then of course just cosine 3x also equals to 0. So to make things a bit easier to follow, I'm going to let 3x equal to z. We need cosine of z equal to 0, which means that z must be pi over 2, 3 pi over 2, 5 pi over 2, or so on. It could also be negative, but because the bounds given in the question are positive, there is no need to check the negative values, as they will of course never be within the bounds. So now I want to check these possible values of z and see if they are within the bounds of x that the question gives. So first, if z equals to pi over 2, then x equals to pi over 6, since of course 3x is equal to z. This equals to 3 pi over 18, which is less than the minimum bound given in the question, 5 pi over 18, which means that this is not a possible value for us. So next let's check z equals to 3 pi over 2. So this means that x equals to 3 pi over 6, which is equal to 9 pi over 18, and that is greater than the minimum bound. It also equals to 1.5 pi over 3, which is less than the maximum bound of 2 pi over 3. So this is a possible value of x, or I guess a possible value of z. And finally, let's check z equals to 5 pi over 2. Here, x ends up being equal to 2.5 pi over 3, which is greater than the maximum bound, which means that this is not a possible value. So we have found just one value of x that might be a minimum or maximum of our function within the given range. And that is, of course, x is equal to 3 pi over 6. So let's plug that into our function. So if x is equal to 3 pi over 6, then sine of x is equal to, sine of 3x is equal to sine of 9 pi over 6, which is the same as sine of 3 pi over 2, and that equals to negative 1. And so previously, we found that at the bounds, this function equals to 1 over 2, and it also equals to 0. And we also just found this local minimum of negative 1. So for the bounds given in the question, our maximum is 1 over 2, and our minimum is negative 1, and those are the answers to this question. Question 5, which says, for the complex number z equals to cosine of 1 over 3 pi plus the square root of negative 1 times sine of 1 over 3 pi, the following equality holds. Z plus z squared plus z cubed plus z to the fourth plus z to the fifth equals to blank. So this is a bit of a weird question since it's asking about complex numbers. I'm guessing that many of you never learned complex numbers in school. I never did, so this might look a little bit scary. But the good news is that this is actually a really easy question if you know just a bit about complex numbers. So if you have the time, I would suggest getting any math textbook or online lessons that has a chapter on complex numbers and doing the first few lessons. It only took me like an hour or two to get far enough into the chapter that I could solve this question. But also keep in mind that there is no other practice exam that asks about complex numbers. So if your exam is coming up really soon and you don't have time, then it may be worth it to just skip this one entirely, and most likely you're not going to get a question like this. I'm also going to try to give an explanation here on how this question works that will hopefully be easy to follow, even if right now you know nothing about complex numbers. But it might be tricky to fully comprehend since I will be sort of rushing through it. If you are studying from if you are studying from a textbook, then the specific things you need to find out are the cis function and Euler's rule or Euler's formula, something like that. And once you know those things, you can probably solve this question. But for now, let's do this small complex number lesson. So the number given is z equals to cosine 1 over 3 pi plus the square root of negative 1 times sine of 1 over 3 pi. So you may have seen this before, which is that I squared is equal to, that the square root of negative 1 equals to 1. This is actually a bit of a bad definition since the square root of negative 1 can also equal to negative I. And so the preferred definition is actually that I squared is equal to -1. So, and that's what makes it a complex or an imaginary number, since normally you cannot get a negative result when you square a number. But the question says the square root of -1, and we will say that it equals to I. Now, in general, if a question looks like this and it has a square root of -1, you can usually assume that the square root of -1 equals to I and not -I. And this question actually doesn't matter which one you will choose, and we'll see why a bit later. So what is an imaginary number really? Well, let's look at a Cartesian grid, which I'm sure you're very familiar with. However, instead of the axes being x and y, we have real and imaginary. Real is just the normal numbers that we're all familiar with, and imaginary is, this new special part. So in general, a complex number has a real and an imaginary part. And so if you plot your number on this grid based on what the real and imaginary parts are, so for example, if your complex number is 3 plus 2i, like this one, then the real part is 3, and the imaginary part is 2i. So you plot it here with 3 units from the origin in the real axis and 2 units from the origin in the imaginary axis. So in general, a complex number will often look like this, with a being the real part and b being the imaginary part. A plus bi. I think that's a common, standard notation. So let's go back to the number from the question. You'll notice that we do in fact have a real and an imaginary part here. So the real part is cosine of 1 over 3 pi, and the imaginary part is sine of 1 over 3 pi, right here, because it's I times sine of 1 over 3 pi. Now we're going to look at something a bit different, but very much related, which is the unit circle, right here. So hopefully you're all familiar with this. For any point on the unit circle, there is an angle. And the x and y values of that point are just the sine and cosine values of the given angle, respectively. So if you have this angle right here, theta, then the point on the unit circle is just cosine theta times sine theta. And if you look at our complex number, you will see that it actually is just like this point on the unit circle. So the angle for cosine and sine is the same, it's just 1 over 3 pi. Also, cosine defines the x value of the point on the unit circle from here. And also defines the real value of the complex number, since we can see here real is along the x. And then sine defines the y value of the point on the unit circle from here, and also defines the imaginary value of a complex number, since imaginary is along the y. So we can imagine our complex number z as a point along the unit circle with an angle of 1 over 3 pi. This is known as the polar form of a number, and you can actually describe any point on the Cartesian plane with it. If you want it to be more or less than 1 unit away from the origin, then you just change the radius of the circle. So the unit circle, of course, has a radius of 1. But if you made it, say, 2, then our point would now be 2 units away from the origin, and our number would look something like this. So if let's say, so right now, z, it has a radius of 1, but if it said had a radius of 2, it would instead look like this. Let me do z2. It would look like 2 times cosine of 1 over 3 pi plus 2 times I times sine of 1 over 3 pi. So, but of course in our question it's just 1, and that actually makes this question a lot easier. If the radius wasn't 1, it'd be a lot more complicated, but that's just something to keep in mind. So now that we've covered all that, there is a new piece of notation to learn, and this is the cis function. So it looks like this. So cis just means cosine imaginary sine, and it's a way of writing our complex number in just a more compact form. So in our complex number, we of course have, let me actually just erase this so it doesn't distract. So in our complex number, we have cosine of 1 over 3 pi and I times sine of 1 over 3 pi. So this can be shortened to cis of 1 over 3 pi. Since again, cis is cosine imaginary sine, and both are cosine and sine of the same angle, so we can just shorten it. And so we can write that our number is z is equal to cis of 1 over 3 pi. And now we need to learn one more rule, which is Euler's rule or Euler's formula. And it says this: if you have a complex number, z, and it is equal to r times cis theta, where r is the radius, then z to the power of n is just r to the power of n times cis of n times theta. I don't think you need to worry about the proof of this. In my textbook, it told me that it's pretty difficult to understand and not really important. You just need to memorize this very useful equation. So our question, of course, asks for z plus z squared plus z cubed and so on. So this rule, we can now analyze those numbers really easily. So z cubed is just cis of 2 times theta. And our theta is, of course, 1 over 3 pi. So z cubed is just cis of 2 over 3 pi. Now z cubed becomes cis of 3 over 3 pi, or just pi. z4 becomes cis of 4 over 3 pi, and z5 becomes cis of 5 over 3 pi. And remember, each of these numbers is just cosine of the angle, so z to the fifth is cosine of 5 over 3 pi plus I times sine of the angle. So it is just a point on the unit circle, right, with a radius of 1. So if you place all of your points on the unit circle, it will look something like this. So z is just a point with an angle of 1 over 3 pi. Z squared is the point with an angle of 2 over 3 pi, and the angle is, of course, it's this angle right here. So for z, it's that angle. For z squared, it's that angle. For z cubed, it's that angle, and so on. Now the question asks us to add up all of these points. And what you'll notice is a lot of these points actually just cancel out. So z, for example, right here, it actually cancels out with z to the fourth. So you can kind of see just in this drawing, right? Z goes to the top right here, and z to the fourth goes in the exact opposite direction. And both of the cis functions have a radius of 1, so they are both 1 unit away from the center. So they cancel each other out completely. And if the drawing doesn't convince you, then of course you could just do this algebraically. Sorry. So z equals to cosine of 1 over 3 pi plus I times sine of 1 over 3 pi, which then just equals to 1 over 2 plus I times square root of 3 over 2. And then z to the fourth equals to cosine of 4 over 3 pi plus I times sine of 4 over 3 pi, which is equal to negative 1 over 2 minus I times the square root of 3 over 2. So if you add these up, clearly they just equal to 0. And so, yeah, so you can see that these points cancel each other out. If you look at this, z squared and z to the fifth also cancel out. And so we end up with only z cubed. Now also earlier I said that if you assume that the square root of negative 1 equals to negative I, you'll still get the same answer. And that's because all that would happen is these values of z would go in clockwise order instead of counterclockwise order. So z to the fifth right here will just be z, z to the fourth would be z squared, z cubed would still be z cubed, and so on. And so you would still have numbers cancel out the same way, and you'd still just be left with z cubed. So now we just need to analyze what z cubed equals to. So this is cis pi, which of course equals to cosine of pi plus I times sine of pi. And cosine of pi equals to negative 1, and sine of pi equals to 0. And so I disappears, right, because it's multiplied by 0. And so the final answer is just negative 1. And it makes sense that I disappears, since if you look at our drawing, z cubed is entirely on the real axis, which means it does not have an imaginary component, so there is no I term. So yeah, and so we found the final answer is negative 1. So hopefully that helped. Again, if you have the time, I would recommend pulling up a textbook or some online lessons or whatever and doing a little bit on complex numbers. It's not that hard, and it won't take very long at all. It took me only probably less than 2 hours to learn enough from the textbook to know what I'm doing. But also keep in mind that this is the only complex number question in all the former exams, which implies that it's pretty unlikely that you will get a complex number question on your exam. So if your exam is soon and you don't have a lot of time left, then you probably don't need to worry too much about it. Next is question 6, which says, let S be a square with side length 1, T a triangle with side lengths 1, 1, and square root of 2, and R a triangle with side lengths 1, square root of 2, square root of 3. Let C be a pyramid with a base that is S and lateral faces consisting of 2 T's and 2 R's. The volume of C then is blank. So for this question, the only thing you need to know is that the volume of a pyramid is equal to 1 over 3 times the base of the pyramid times the perpendicular height of the pyramid. So kind of like a triangle, except it's 1 over 3 times instead of 1 over 2. So the problem with this question is that the faces of the pyramid are different sizes, so it's not very straightforward to find the height. So I have to do a little bit of problem solving. So in general, you should always start by drawing a diagram for a question like this. The question tells us that the pyramid has a square base with side lengths 1, so we start by drawing that. Then it has 4 triangular sides. A key thing to keep in mind is that for this to be a proper pyramid, the sides touching each other must be the same length. So a square base has all sides of length 1, so all 4 triangles must be attached to it with their sides that are a length of 1. And adjacent triangles must have the same length of sides. So with that in mind, we can start putting together what this pyramid could look like. So to start, let's put one of the triangles that has 2 sides of length 1 and 1 side of length square root of 2. So the first side of length 1 will just be the side that's attached to the base. Then we'll have another side of length 1 right here. And then we'll have the side of length square root of 2 here. So I'll label that this is square root of 2 and this is 1. So since it's the first side, you could always put it wherever we want. And I'm drawing it like it's a mesh or net of the object, which is why for now it'll just be flat. Now to add another triangle, we have to make sure that the sides match. So this side has a length of 1, meaning the triangle touching it must also have a length of 1. And you'll realize that there's actually only one triangle that can fit here, one triangle that can attach to this side. And that's the triangle that's the same as this one, the one that also has 2 sides of length 1 and 1 side of length 2. And that's because the other 2 triangles, the question says their triangle R, only has one side that has a length of 1, and that side must be attached to the base, since the base has all sides length 1. So that means that those triangles with side lengths 1, square root of 2, square root of 3 can't go on this side because then they wouldn't be able to match this side. So the only triangle that can go here is the other triangle that has 2 sides of length 1 and 1 side of length square root of 2. So we now also have this triangle right here. So we could add the other triangles, but you can actually already solve the question without doing that. And that's because if you folded these 2 triangles up to actually start making the pyramid, you'll see that they must come together when both sides are facing straight up, when there's a 90-degree angle here. So this means that we have already found the height of the pyramid. It has to be 1 unit tall, since that's the length of this side, and it's going straight up. So you can also try drawing it in 3D to get a better view of that. So this one of the triangles is here in green, and the other one is this one that's in blue. And as you start folding up the 2 sides to make the pyramid shape, they come together at this right angle, meaning they are pointing straight up. And this side has a length of 1 unit, which means the height must be 1 unit. So with that, we can find the volume. The volume is just 1/3 times the area of the base times the height. The base is a 1 by 1 square, so its area is 1, and the height is 1. So the volume is 1/3, and that is the answer to this question. So next is the section 2 question, which says, on the xy plane, a circle with center a, b, and radius r is tangent to the parabola y equals x squared at 2 distinct points. Fill in the blanks with the answers to the following questions. First is when one of the 2 points of tangency is t, t squared. Express a, b, and r in terms of t. So to answer this question, you just need to know how to find the areas of a few different shapes on a Cartesian grid, including some basic integrals. You also need to be able to find basic derivatives and make use of tangents to a curve. So first, as always, you should start with a diagram. So let's go through this one that I made. So to start, I drew the parabola that's given in the question, y equals x squared in green. I then drew the circle, which is tangent to the parabola at 2 distinct points, this one and this one. What that means is that there are 2 points where the circle just touches the parabola for a moment, and at those points, that part of the circle is parallel to the parabola. I then labeled the point t comma t squared right here, and I labeled the center of the circle a comma b, and I drew the radius since these are all values in the question. I also labeled h right here, but I will explain that later. So of course, when drawing your diagram, you can add on to it as necessary. So you might not have h at first, or your diagram might look a bit different at first. So anyways, firstly, notice that the circle touches the parabola at 2 points, t squared right here and negative t squared here. So unfortunately, I can't really give like a solid mathematical reason for why it is that the circle is symmetrical like this. I tried to think of something for a while, but I couldn't make any really great explanations. The best I can say is that it's kind of intuitive, since the parabola is symmetrical along the y-axis and the circle is symmetrical, and a circle is symmetrical through the middle. So it stands to reason that the circle would be centered right on the line of symmetry of the parabola. But again, sorry, I don't think I can give a more clear reason. Hopefully it just makes sense to you like it did to me, that the circle should be right in the center in order to be tangent to the parabola at 2 distinct points. But yeah, because of that, the other point where they touch must be negative t comma t squared. Also, because the circle is centered, we know right away that the value of a must be 0, since the center of the circle is on the y-axis. So that's already one part of the question, a equals to 0. Next, for b, we notice that b is t squared, which is the height up to this point, plus h, which is the height from the point to the center of the circle. So I have that written down over here. We can also say that h equals to b minus t squared. But the question wants these values in terms of t, and right now I have too many unknowns with h and b, so we can't use these for now and just leave them for later. Instead, what we can do is consider the fact that the circle is tangent to the parabola at these 2 points. So what that means is that those exact points, the radius of the circle must have a slope that is a negative reciprocal to the slope of the tangent line. So this is just a common fact used in problems like this, which is that if you have a line with a slope, then a line that is perpendicular to the first line will have a slope that is the negative reciprocal of the first line. So if you have a line with a slope of m, then a line that is perpendicular to that slope will have, or a line that is perpendicular to the first line will have a slope of negative 1 over m. So we can use the derivative of the parabola to find the slope of the tangent line, which is just 2x from the power rule. And that means that the slope of the line that makes the radius must be negative 1 over 2x, or negative 1 over 2t. However, we can also find the slope of the line that makes the radius just using rise over run. So the rise is from t squared to b, and the run is from t to a. So let me show you that the rise is from right here, t squared to b, and the run is of course from t to a. So we now have two definitions of the slope of the radius line. That means that we can make them equal each other. And of course, remember that a is just equal to 0, so we don't have to include it anymore. And so we can make them equal to each other. And when we do, we end up with an equation with only b and t, which means we can express b in terms of t, which is what the question is asking for. And of course, we remember, So now if we rearrange this a bit by multiplying both sides by negative t and then moving all the t terms to one side, we find that b equals to 1 over 2 plus t squared, which is the second part of the question. So now let's try to find the radius. So you can see from the diagram that this is clearly a right triangle here with sides t, since it's from the y-axis 0 up to the point t, h, and r. So that means that r squared equals to h squared plus t squared from Pythagorean theorem. And we already found that h is equal to b minus t squared. And so if we plug that in, right, r squared is equal to t squared plus h squared, we plug that in, we now get that r squared equals to t squared plus b minus t squared squared. And of course we just found the value for b over here, so if we plug that in, we end up with r squared equals to t squared plus 1 over 2 plus t squared minus t squared squared. Of course, we have plus t squared and minus t squared here. They just cancel out. And so we get that r squared is just equal to t squared plus 1 over 4, which means that r is equal to the square root of t squared plus 1 over 4, and that is the answer to the third part of the question. So the next part of the question is, when one of the 2 points of tangency is 1 over 2 comma 1 over 4, express the area S of the finite region bounded by the circle and the parabola in terms of pi. So if you look at the diagram, what that means is that we need to find this area right here. So between the circle and the parabola, that is the area that we are looking for. Also, it tells us the exact coordinate of the point, so we can change it. So instead of just t comma t squared, we can say it's exactly 1 over 2 comma 1 over 4. And since this is symmetrical, we now know that this other point is just negative 1 over 2 comma 1 over 4. So to find this area, you might think to do an integral where you find the area under the circle and subtract it from the area under the parabola. But that'll be a pretty hard integral since the equation of the circle will have a square root in it, and it will end up getting pretty tricky. So it's actually an easier way to find this area using geometry. So what you can do is you can add and subtract different areas that are easy to find in order to end up just with the area that we're looking for. So I suggest that you pause and try to figure it out on your own before I show it to you. So anyways, firstly, what we can do is we can find the area of this rectangle, quite easily. So this rectangle right here, highlight it in green. We can find this pretty easily. And then we can also find the area of this triangle. So let me select the right color. And by the way, speaking of colors, you may notice I used a lot of colors in my diagram, and I definitely suggest going to the exam with like a bunch of colored pens or pencils. That's what I did. I had like 20 pens on my desk and they didn't say anything, so you can do it, and it's pretty helpful. You have to draw a diagram like this. Oops. So yeah, we can find the area of this triangle over here. So if we add up these areas, we have all this. Now what we can do is we can subtract the area underneath the parabola. So that's like basically the same color. Let me try something else. These color choices aren't great. So we can subtract the area underneath the parabola, and that's just an easy integral. And finally, we can also subtract I'm just gonna use the same color. We can also subtract the area of this whole slice over here. And then if we do that, the only area we have left is this area between the circle and the parabola, which is what we're looking for. So let's start with the area of the rectangle, which is very easy. So the base of the rectangle, or the width, I guess, is 1, since it goes from negative 1 over 2 to positive 1 over 2. And the height is 1 over 4, so the area is 1 over 4. Next, we can do the area under the parabola. So it's an integral of x squared. Because it's symmetrical along the y-axis, I'll do the integral from 0 to 1 over 2 and multiply it by 2. This is just a simple power rule integral. And so if you solve for it, you will find that the area under the parabola is equal to 1 over 12. So next is the area of the triangle. So of course the area of a triangle is just 1 over 2 times the base times the height. We know that the base has a length of 1 since it goes from negative 1 over 2 to 1 over 2. We know that the height is h, and we know from before that the height is equal to b minus t squared. And we also know from the last question that b is equal to 1 over 2 plus t squared. So from that we know that the height of the triangle is just equal to 1 over 2. And so the area of the triangle is equal to 1 over 4. Now finally I have the area of the slice. I wrote circle here, or circ, but what I meant is just a slice of the circle that we care about. So the area of a slice of a circle is 1/2 times theta, which is the angle in radians, times the radius squared. Yeah, so we know what the radius is from the last part of the question, and so the radius squared is equal to t squared plus 1/4. We know that t squared is just the y value of our point, which is 1/4, and so we get that the radius squared is equal to 1/2. So now we need to find the angle. So the angle we're looking for is theta, which I will draw on the diagram. Okay, let me actually erase these parts so we can see. Whoa, what did I just do? What on earth? Sorry about that. So the angle is theta, which is right here. But in order to make it easier, what I'm going to do is I'm just going to consider phi, which is like this half angle, and I'll multiply it by 2. Because if I do that, I'm working with a right triangle, which makes things a lot simpler. So we have that theta equals to 2 phi. And so because this is a right triangle, we can use that tangent of phi equals to opposite over adjacent. Opposite is just the distance to x, which is 1/2 or 0.5, and adjacent is height. And of course, we just found that height is 1/2 or 0.5. And so tangent of phi is just equal to 1. And if we do inverse tangent on both sides, we find that phi is equal to pi/4. And theta is, of course, 2 times phi, and so it equals to pi/2. So now we can find the area of the slice, and it equals to pi/8. So now we're ready to find the final area that we're looking for. So we add the area of the rectangle and the triangle, and we subtract the slice and the area under the parabola. And what we end up with is that the area is 5/12 minus pi/8, and that is the final answer to this question. So finally we have section 3, which says let f of x equal to the integral from x to 0 of 1/1 plus t squared dt, x is greater than 0, and g of x equals to f of 1/x. Fill in the blanks with the answers to the following questions. So to answer this question, you need to know the fundamental theorem of calculus. I will link a video in the description that explains the fundamental theorem of calculus much better than I can. Also, you need to know that 1/1 plus x squared is a special integral, and it equals to the inverse tangent of x. This is something that we were just expected to memorize when I took calculus in university, but I will also link a video that shows how to derive it if you don't just want to memorize it blindly. And of course, you need to know how to find derivatives. So with that, you're now ready to answer this question. So firstly, let's call this function that is inside the integral given as h of t, since we already have functions of f. So h of t is just equal to 1/1 plus t squared, which is the function inside of our integral in f of x. So now the question asks us to find the derivative of f of x. And from the fundamental theorem of calculus, we know that if f of x equals to the integral of h of t from x to a constant, which it does, then the derivative of f is just h of x. So f prime is h of x, which is just 1/1 plus x squared. And that is the answer to the first part of this question. And by the way, f prime, which is, this symbol right here is prime, is just the derivative of f. Next, we need to find g prime. So notice that g is just f of 1/x. So to find g prime, we have to use a chain rule. So we find f prime, or the derivative of f, of 1/x, and then we multiply it by the derivative of 1/x. So we already found f prime in the last question, so we just sub in 1/x instead of x right here. And the derivative of 1/x is just negative 1/x squared from the power rule, from the power rule. So we multiply these together, we simplify it a little, and you find that the answer is negative 1/x squared plus 1, and that is the answer to the second part of the question, that is g prime. So next we need to find the value of f of 1. So to do this, we're just going to plug in 1 for x in the function of f. So we have the integral from 1 to 0 of 1 over 1 plus t squared. So remember that this is just a special integral that you need to memorize. You technically could derive it on your own, but you need to be familiar with trig substitutions, which as far as I know are not normally taught in high school courses, even advanced ones. So anyways, yeah, you just have to, this is just an integral that you have to memorize. And so the integral is inverse tangent of t from 1 to 0. So we need to find the inverse tangent of 1 and subtract from it the inverse tangent of 0. So I will set the inverse tangent of 1 equal to a, which means that the tangent of a equals to 1. So a must be pi over 4. I then set the inverse tangent of 0 equal to b, which means that the tangent of b equals to 0. So b must be 0, and therefore f of 1 is just pi over 4, and that is the answer to this part of the question. So next it says that f of x plus g of x equals to a constant c. And what this means that no matter what x value you use, f of x plus g of x will always equal to c. That means we can use whatever x value you want to find c. And you'll notice that by far the easiest x value to use for this is just 1. Because firstly, we already found f of 1, so we already did half the work. And secondly, you'll notice that g of 1 is just f of 1 over 1, which is just f of 1. So we don't have to do any more work, since again, we just found f of 1. So this is just pi over 4 plus pi over 4, which is pi over 2, and that equals to c, and that is the answer to this part of the question. And finally, we have the limit as x approaches infinity of f of x. So if you've taken an introductory calculus course, or I guess derivatives course, then you should probably be familiar with this notation. It's basically just saying that x equals to infinity. The only reason why we don't just write x equals to infinity is because, technically speaking, infinity isn't actually a number, so x can't equal infinity. So instead we say that x is approaching infinity, meaning it gets closer and closer to infinity. So anyways, we need to find f of x as x approaches infinity. So this is just like when we found f of 1 before. So we have the inverse tangent of x from x to 0. We already found that the inverse tangent of 0 is just 0, so we end up with the limit as x approaches infinity of the inverse tangent of x. So to find out this equals to, I'm going to say that L equals to the inverse tangent of infinity. Now technically this is not proper math, and if you wrote this on an exam where they are grading your work, you would probably lose marks. I definitely would if I did this in my calculus course. But in this case, they're only grading your final answer, so it's fine. So if L equals to the inverse tangent of infinity, then tangent of L equals to infinity. And tangent becomes infinitely big as the angle approaches pi over 2. So therefore, L equals to pi over 2, and so the limit as x approaches infinity of f of x equals to pi over 2, and that is the final answer. So that's it for this exam. I hope you found this helpful. If you have any comments or questions about this exam, please leave a comment and I will try to help you if possible. And if you're writing the MEXT exam soon, then good luck and have a good day.